Dear students, in the last two videos we discussed about extreme values of a function. So in this video let us solve a question. Find the absolute maximum and minimum values of the given function on the given interval fx equals square root of 4 minus x square on the closed interval minus 2, 1. So first let us differentiate the function fx. Using chain rule, f prime x will be equal to 1 by 2 square root 4 minus x square multiplied by 0 minus 2x. This will be equal to minus 2x over 2 square root 4 minus x square. 2 cancels with 2. Therefore, f prime x is equal to minus x over square root 4 minus x square. Now, before starting to find the critical points, first we will observe the given interval. The given interval is the closed interval minus 2, 1. This means that x is greater than or equal to minus 2, x is less than or equal to 1. If we observe this closed interval on the number line, we will have two conditions which are of our interest. The first condition will be that x is greater than minus 2. And second condition will be that x is equal to minus 2. The first condition will give us minus 2 whole square will be greater than x square, and this gives us 4 is greater than x square, and hence 4 minus x square is greater than 0. The second condition will give us that minus 2 whole square will be equal to x square, and this gives us that 4 is equal to x square, and hence 4 minus x square is equal to 0. If we combine these two, we can surely say that 4 minus x square will be greater than or equal to 0. This expression or condition will be very useful now. Let us find the critical points. So we have already calculated f prime and we have found this condition also. So from this condition we have two conditions. So one by one we will discuss. The first condition is when 4 minus x square is greater than 0. In this case, f prime x will be minus x over square root of 4 minus x square. We know that for a critical point, we should have two cases. The first case is that f prime should be not defined. The second case is that f prime should be equal to 0. If I say the first case, the first case is clearly not possible, because when 4 minus x square is greater than 0, it means that square root of 4 minus x square will always be non-zero number, and hence this expression will always be defined. So we can write that the first case is not possible. Now let us see the second case when f prime is equal to 0. This will give us minus x over square root 4 minus x square is equal to 0. Because 4 minus x square is greater than 0, and hence square root of 4 minus x square will be non-zero number, and hence we can cross multiply. So after cross multiplication we will get minus x is equal to 0, and finally we will get x equal to 0. This is our first critical point. Now let us discuss condition number 2 when 4 minus x square becomes equal to 0. In this condition, f prime x is equal to minus x over square root 4 minus x square. And because 4 minus x square is equal to 0, hence square root of 4 minus x square is also 0. So this gives us minus x over 0. For critical point, we have case number 1, that is f prime should be equal to 0, and we have case number 2, that is f prime should be not defined. If we see, clearly we can state that case number 1 is not possible because this expression will never become equal to 0. So we will write this case is not possible. Whereas the second case, that f prime should be not defined, this expression is always not defined because here we have a division by 0, and we know that division by 0 is not defined. Therefore, this case is always true in this condition. Therefore, we have 4 minus x square is equal to 0, and this gives us 4 is equal to x square, and this gives us x is equal to square root of 4, can be positive, can be negative, and this gives us that x is equal to positive 2 or negative 2. But our domain is the closed interval minus 2, 1. Therefore, the positive 2 is out of our domain. So we have to reject this point. Whereas negative 2 is inside our domain. So we will consider negative 2. Therefore, we can say that x is equal to minus 2 is our critical point. Now we will evaluate the values at the critical points and the end points, and then we will decide which is the absolute maximum and which one is the absolute minimum. So our critical points are x equal to 0 and x equal to minus 2, and our end points are x equal to minus 2 and x equal to 1. So if we calculate the value of the function f at 0, we get square root of 4 minus 0 square. This gives us square root of 4 and this gives us 2. Let us calculate the value of the function f at minus 2. That will give us square root of 4 minus 2 square. That will be square root of 4 minus 4. That will be square root of 0. That will be 0. And same way, let us calculate the value of the function f at 1. This will give us square root of 4 minus 1 square. That will be square root of 4 minus 1. That will be square root of 3. So we have evaluated the values of the function at our critical points and our end points. Now if we observe, out of these three values, the least value is 0. So 0 is the absolute minimum value. If we observe the three values, we can see that 2 is the largest value. So we can write that 2 is the absolute maximum value.